We're a couple of hours away from low tide. It's time to get in the water. It's deployment day for this team from the University of Florida. They're attaching 6 water pressure sensors to a bridge along Florida's Atlantic coast, an area often in the crosshairs of a hurricane.
These are oftentimes the only way that people can evacuate those regions and that emergency services can get into those regions. So they're really important from that perspective.
With support from the National Science Foundation, civil engineer Jennifer Bridge and her colleagues want to understand how to make bridges safer and provide an early warning if a bridge has been damaged by a storm. To do it, they've developed this bridge-mounted sensor system to collect data at the source and transmit it back to their lab in real time during a hurricane.
There have been lab studies to look at wave and surge loads on bridges, but to date there hasn't really been anything on bridges, especially during storm events.
They're particularly interested in looking at concrete bridges vulnerable to hurricanes in low-lying coastal areas.
These are the type of bridges where we saw failure during Katrina and Ivan and previous hurricanes, where you would see the deck kind of came off the supports of the bridge.
21 right now.
The day before the deployment, the team did some final tests on the sensors back at the lab. Grad student Carlos Soler Ayoroa showed us the inner workings.
So this is the actual pressure sensor that's inside the PVC enclosure that's going to be attached onto the bridge.
The next morning, they loaded up their truck and hit the road early, headed for the coast.
We've put a lot of effort into identifying structures throughout the state that are vulnerable, that are appropriate, that are accessible, so that we can go in directly ahead of a storm and try to get the data we need.
Eventually, they plan to rapidly deploy in front of approaching storms to wire up bridges immediately in harm's way.
Right now, we're still operating in the mode of let's just put it out for the hurricane season in as many locations as we can and cross our fingers.
Data from water pressure sensors can tell them a lot about what's going on at the bridge during a hurricane, like water levels and storm surge measurements. They're also gauging impact loads, forces generated by water pounding the bridge from the side every time a wave hits.
In order to capture the impact forces on the bridge piers, we're measuring pressure, the water pressure, both on the front of the pier and the back of the pier, and by looking at the difference between those two pressures, we can get that horizontal force.
Cables connect the sensors to a solar-powered hub located up on the bridge deck. Here the data is recorded and also streamed back to the university wirelessly. They're tackling a difficult hardware and software challenge to put together a system robust enough to keep operating under hurricane conditions.
We do have storage in our system on site, so should we lose communication, we can go back in later and try to extract that data. Now, that's assuming that the brains of our sensor system haven't also been washed away. The way that we try to prevent that happening is that system is up on higher ground, so we try to put that in a less vulnerable location.
At the end of the day, they still had some work to do tying down all those cables. They went back a few days later and finished the job.
What we're measuring right now is the wave and the water loads on the structure. What we're not measuring right now is how the structure is responding to those loads. So the types of sensors we may add in the future will be sensors that can actually capture the response of the structure.
Engineering more resilient infrastructure, understanding better what's happening with coastal bridges when they ride out a storm. For Science Nation, I'm Miles O'Brien.